Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2014, 10A, Problem 15, and it deals with speed and distance. I hope you all enjoy this video, and let's get started. The problem states David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes that he will be 1 hour late if he continues at this speed. He increases his speed by 15 miles per hour for the rest of the way to the airport and arrives 30 minutes early. How many miles is the airport from his home? To make this question simpler, I'm going to draw out a diagram. So for example, this is his home, and this will be the airport. So according to the second sentence, he drives 35 miles in the first hour. So for example, 35 miles is going to be right here. So that means that this distance is 35 miles. But because he drives 35 miles in the first hour, that means that he drove 35 miles in 1 hour. So that would be his speed. So this is 1 hour. And then this is the rest of the way. And he realizes that he will be 1 hour late if he continues at this speed. So that means the speed for the rest of the way is also 35 miles per hour. And then let's draw out the little diagram for the next bit of the question. So, home. So both of these scenarios, he starts off by driving 35 miles in the first hour. But in the second scenario, he increases his speed by 15 miles per hour for the rest of the way. So this would be the rest of the way, and he increases his speed. So that means it would be 35 plus 15, which is 50. So for the rest of the way, in the second scenario, his speed is 50 miles per hour. And in the second scenario, he arrives 30 minutes early. So the question is, how many miles is the airport from his home? And we will just let that be x. So let number of miles to airport from home be x. Well, we can set up an equation revolving around the fact that in the first scenario, he arrives 1 hour late, and in the second scenario, he arrives 30 minutes early. So how do we express his time in the first scenario? Well, we already know that he starts off already at 1 hour, so it would be 1. And then we can add that to the remaining time, which we don't know. But we do know that distance over speed equals time. That is a formula that is very important. And I'll just write it out right here. So distance over speed equals time. And we can just plug that in. So what is the distance? Well, we set the whole distance from his home to the airport to be x. So that means that the remaining distance after he traveled for an hour, so it'd be this segment, this will have to be x minus 35, because remember that I already told you that he drives 35 miles in the first hour. So that's 35. The whole is x, and that means that the remaining would be x minus 35. So that is the distance. And then it is distance over speed. Well, we already know that his speed is 35 miles per hour, so it would be 35. So that is the time that it takes in the first scenario. And remember that this time causes him to be 1 hour late. And then let's try to solve for the time in the second scenario. Well, just like before, we already know that he spends 1 hour at first, and then it's the same thing. Because this whole distance from his home to the airport is x, then this is 35, and that means the remaining would be x minus 35. The only thing that changes here is that the speed is not 35 anymore, but it is 50, because he increases his speed by 50 miles per hour in the second scenario. And so this would be his time in the second scenario, in which he arrives 30 minutes early. Okay, and as I just said, that I would like to set up an equation in which it revolves around the fact that he arrives 1 hour late the first time, and then he'll arrive 30 minutes early the second time. So how I thought about it was that, for example, I'm just going to draw a little line right here to represent what I'm about to explain. So if he needs to get at the airport at 10 o'clock, right? 10 a.m. Let's just, right? That is his goal. He needs to be there by 10. But then according to the first scenario, if he drives at 35 miles per hour, then he will arrive there 1 hour late. So for example, this is according to the first scenario. And by the way, the whole diagram is representing time, not distance. So this means that this is 1 hour late, and he's going to arrive there at 11 o'clock. But then if he increases his speed by 50 miles per hour, according to the second scenario, then he will arrive 30 minutes early. So that means that this is the second scenario, where he arrives 30 minutes early. And so he will get there at 9:30. Well, then the difference between these two times would be 1.5 hours. So this whole part, that is 1.5 hours. And why do we need this? Well, if you see the first scenario time, right? This is the time that it will take him to get to his airport in all. This is all the time that it needs for the first scenario. And then this is all of the time that it takes in the second scenario. Well, we already know that the time it takes in the first scenario is longer than the time that it takes him to get to the airport in the second scenario. So if we subtract the time it takes in the second scenario from the time it takes in the first scenario, that would give us the difference between the two times. And we just found out that the distance between the two times is 1.5 hours. So basically what I'm saying here is 1 plus x minus 35 over 35. So this is what I'm saying. And so now we just have an equation that revolves around x, and all we need to do is just solve for x to get the answer. Okay, so in the end, we solved for x and we got x equals 210. And so the answer is C, 210. And just to note that the way I solved it here, there's multiple ways to solve it. But how I solved it, this part right here, this part, all I did was I separated these two into this, like, and then this. So for example, x minus 35 over 35, that would give us x over 35 minus 1, and then x minus 35 over 50 would give us x over 50 plus 35 over 50, which I simplified to be 7 over 10. And then from there on, it's pretty much just simplifying everything, and yeah. But the answer is C, 210.